Hello students, this is the recording on the 5B lesson for motors. So let's go ahead and do a quick brain stretch. So we want to know what's going to happen with these magnets. We have a south pole and a south pole. Will they attract or repel? And what will happen to these electric charges? We have a positive and a negative. Will they attract or repel? Pause the video, continue playing once you have an answer. All right, so taking a look here, you should know that south and south are both like poles. And anytime you have likes, all right, this means that in both electricity and in magnetism, that likes will repel. All right, on the other hand, these charges down here are opposite charges, and similarly, opposite charges or opposite poles in magnets are going to attract. All right, so again, we talked about how likes repel, opposites attract, and this is true for both magnets and for electric charges. All right, this is going to be the answer for number 2 and number 3. All right, so number 2, they are going to repel, and the reason why is because they are like poles, whereas number 3, they will attract because they are opposite charges. Pause the video, continue playing when you have number 2 and number 3 completed on your notes. All right, so let's go ahead and take a look at our schedule here. So we only have 9 days left of trimester 3, or the entire school year, and then courses are over. Nothing will be accepted after the last day. Courses close at 11:59 p.m. There will be no extensions. So we are taking a look at 5B motors today. Don't forget that you do have an exam coming up soon, and that exam will be on Wednesday, but it will be zeroed out on Thursday. So you have a bit of a grace period there. All right, let's talk about STAR 360. Don't forget that at this point you should have STAR 360 completed, and that we did move that exam again so that it did not conflict with STAR 360. So again, it will be due on Wednesday, and then it'll be zeroed out on Thursday, and then you have a week to make up any missing work or any missing projects or exams. Remember, you should focus on projects and exams, and since they're worth 70% of your grade. It's literally a waste of time if you're doing other things besides the projects and exams at this point, so don't waste your time, don't waste our time. Please make sure you get your projects and exams done correctly. Please make sure that you are watching the recordings. At this point, I am now on maternity leave. Your teacher, Mrs. Sepulveda, has actually come back. She was out on leave for trimester 3, which is why Mr. Bangle is here. Mr. Bangle is still here because obviously, again, now I am out. But she is a full-time physical science teacher, so she can also help you with projects and with the future exam that is coming up. So please make sure if you are my roster, you are now on her roster, and she is a great resource to make sure that you are being successful. So please contact her if you need help. So today we're going to talk a little bit about how electricity and magnetism interact in a thing called an electromagnet. We'll also talk about how they interact within a motor. You should open up your 5B notes if you haven't already. Remember, if you can't find them, they are in your grades tab. Everything is in your grades tab. Your grades tab is your one-stop shop. There are no excuses. You should always be able to find everything you need in your grades tab. Let's go ahead and do a quick brainstorm. The question is, what are some things in your house that need a motor to spin? Pause the video, continue playing once you have an answer. Well, here are some things you might have thought of. You might have thought of things like your motors in your car, right? You might have thought of like blenders or fans. All of those things have different motors. All of those things do spinning motions, which is why motors are super useful. All right, let's go ahead and talk a little bit about how motors are related to electricity and magnetism. So electricity and magnetism are actually related to each other. I know it was a little bit weird in our previous lesson. We kind of talked about them separately. But here's the thing, electricity can actually cause magnetism. So for example, if you take a look here, when you have an electric current moving through a wire, you can't see it, but around that electric wire, there is a magnetic field being produced. Now, a lot of times it's a really small magnetic field, which is again why we don't notice it, right? You could put a magnet up to the wire and usually the wire won't do anything. But there are ways in which we can actually strengthen this magnetic field. So again, electric current in a wire can actually produce a magnetic field around it. All right, and the reverse is also true. Magnetism can actually cause electricity. So for example, if you take a magnet and you move it through a coil of wire that has no electricity moving through it, it's not plugged in or anything, this can actually also result in an electric current. Let's go ahead and take a look at a video of that, or a GIF of that really quick. All right, so taking a look here, again, this wire right here is not attached to anything electrical. It's not plugged into a wall or anything. It's literally just a plain piece of wire. But if you were to push a magnet in and out of that plain piece of wire, what you would see on a voltmeter is that you would see that it is actually producing electricity. So again, magnets can actually also produce electricity, which is crazy to think about. Again, they're both related to each other and they can both produce each other. Now, what motors do is motors specifically take advantage of how electricity and magnets interact. So it takes advantage of these relationships. Let's go ahead and talk about a simpler example first, though, before we talk about motors. So over here we have what's called a solenoid, and a solenoid is a coil of wire, right, which you can see right here. And if you have electricity flowing through this coil of wire, this actually results in a magnetic field that looks a lot like a real magnet. Now remember, we saw that, again, an electric current does produce a magnetic field. However, that magnetic field is kind of circular. However, if you actually make the wire circular, then that magnetic field begins to straighten out. So you can actually see now we have a very specific North Pole and a very specific South Pole, which looks very similar to the North Pole and the South Pole of a regular good old magnet. So we have a magnetic field that looks a lot like a real magnet. Now, we can also make what's called an electromagnet, which is very similar, all right? It's also got a coil of wire, but this time electromagnets are actually a stronger version because they have a core that can also be magnetized, and usually that core is iron. So you can actually see here, this looks identical. Again, there's nothing magnetic here, right? So there's no magnet here, but once we have electricity moving through here, that electricity begins to form a magnetic field that we can further strengthen by having iron in the middle of it, okay? So let's go ahead and fill in number 4 with the word solenoid. Make sure you spell it correctly. Pause the video, continue playing when you're ready. All right, so let's go ahead and take a look at how this idea of making the wire a coil actually makes electromagnets work. So again, we already kind of saw this picture that when we have electricity going through a wire, there is a magnetic field that is produced around it. Again, without any real magnets, all right? So this magnetic field right here is very, very weak, all right? So again, you don't notice that magnetic field in your everyday life, right? When you're charging your phone, you don't notice the magnetic field that's being produced around the wire of your phone charger. However, if you begin to wind these wires over and over and over again, eventually that magnetic field begins to build up on itself and gets a lot stronger. So not only does it begin to straighten out, right? So you can see it begins to get straighter inside of here, but it also gets a lot stronger. And you can make this even stronger by putting in a core of iron inside of it, again, because that iron can actually take advantage of that magnetic field and make it much stronger. Okay, this is actually something that you can do at home. So if you do have a battery and copper wire, you can actually wrap a copper wire around an iron nail and then attach it to the ends of the battery, and you can actually see how it becomes magnetic. Pretty cool. But please make sure you have parental supervision, and again, you can always Google how to make an electromagnet if you need more instructions. All right. So you can see an example of what I was talking about here, right? So we can see a copper wire being wrapped around an iron nail and then being attached to the ends of a battery. So this is electricity moving through here, and that electricity is actually producing a strong enough magnetic field that it can actually pick up something like a paper clip. Now the cool thing about electromagnets is that because they are powered by electricity, it's actually much easier to turn them on and off, whereas real magnets you can't turn off, but electromagnets you actually can. Now this is really helpful. Think about, for example, this giant magnet on the top of this crane to pick up a car. If that was a real magnet, first off, it would be crazy expensive. Second off, you would pick up the car and then never be able to drop the car. Whereas with an electromagnet, a magnetic field being powered by electricity, all you need to do is cut the electricity from our generator, and then you can drop the car, right? So that is one of the great purposes and reasons that we love electromagnets. They're also going to be a little bit cheaper to make than to try to find a huge real magnet. Let's go ahead and take a look at this electromagnet in action. All right, so taking a look here, you can see up here, this coil of wire, right? So that coil of wire, again, is our electricity. It does have a core of iron that you can see here, which makes it even stronger. And you can see that there's a button here that this person is pressing to turn it on and off. Now, this right here is called ferrofluid. It's basically little magnetic particles suspended in fluid. And so what happens is that as you turn it on, that metal is attracted to our electromagnet. Whereas once you turn it off, it drops to the bottom. So again, that just really demonstrates that this is something that you can turn on and off, which we can take advantage of. Go ahead and pause the video and answer this question. An electromagnet has which of the following components? A straight wire with a current, a coil of wire with a current, or no wire. And then also no core, a core that cannot be magnetized like aluminum, or a core that can be magnetized like iron. Pause the video, continue playing once you're ready. All right, so taking a look here, the correct answer is that electromagnets have two things. They have a coil of wire with an electric current, and they also have a core that can be magnetized like iron. Again, if it has a coil of wire but no core, this is just called a solenoid. So electromagnet is defined as having both of those. This is number 5. Go ahead and pause the video and continue playing when you're ready. Okay, so we talked about a kind of simple example of how electricity and magnetism interact with an electromagnet. Now we're going to go ahead and take that a step further and talk about motors. All right, so motors are when we have rotating coils of wire. Again, we kind of learned about what those coils of wires are. Those are called solenoids or electromagnets, right? They're often used pretty interchangeably, although electromagnets technically should have a core in them. But they're being powered, so in an electric motor, we have solenoids or electromagnet being powered by a magnetic force. Now, this is due to a real magnetic field, all right, interacting with another magnetic field that is being temporarily produced by an electric current, again, that solenoid, all right? Now, we can see here, right, so here's our electricity coming from our battery through this coil of wire, and so this right here is going to produce an artificial or temporary, right, magnetic field, one that we can turn on and off. On the other hand, down here we have a real magnet, okay, and this real magnet is going to have a real magnetic field. And what we're going to see is that these two things are going to interact, and they are going to go ahead and cause our motor to spin. So electric motors, their whole purpose is they take electrical energy from like a battery or from an outlet, and they are able to convert it into kinetic energy. Remember that the word kinetic means motion, and specifically they're turning it into a spinning motion, right? That's why motors are used for spinning wheels on a car or for spinning blades on a fan or in a blender. Okay, this is going to be number 6. Go ahead and fill in the blank with the word current, only the word current. Pause the video, continue playing when you're ready. All right, so taking a look here, what again is the starting versus ending energy in a motor? Pause the video until you have an answer and then continue playing. All right, well, we did mention that again, we start off with a battery or with a electrical outlet, so that means we're starting off with electricity, and then it eventually gets turned into kinetic energy being that spinning motion. This is the answer to number 7. Pause the video until you're ready to continue. Okay, so let's go ahead and talk a little bit about how motors are set up a little bit more, okay? So when you start a motor, there are a few steps here. So to start off, you have an electric current that is going to flow through a coil of wire, through your solenoid, okay? So you can see here in green, I've marked that off as our green step. So you can see our electricity is moving from the battery up through this needle, which can carry electricity, through the wire, which is carrying electricity, to the other needle, and back to our battery. So we're creating a closed circuit here where electricity can flow around and around and around. All right. Now what's happening is, again, we have a coil of wire, and anytime you have a coil of wire, all right, that means that you are producing a temporary magnetic field. So you have a magnetic field being produced by this electricity. Okay. So here is our temporary magnetic field right here. Now, the next part is that we have a real magnet right here. And so this real magnet is able to then interact with the temporary magnetic field that we just created. So our middle step is now they begin to interact with each other. Now you'll notice that this wire is not like locked into place. And so since it's not locked into place, it is now able to spin. So this is going to push and pull on this temporary magnetic field on this coil, and that pushing and pulling is going to cause this coil to begin to spin. So now what we have is we have electrical energy from a current from our battery being turned into motion or kinetic energy, this spinning that's happening right here. Okay, let's go ahead and take a look at that a little bit more in action on a GIF right here. All right, so let's go ahead and pop this up here. All right, and we can actually see how this is happening. So this is really cool. All right, so again, we have step one, an electric current going through this loop here. Okay, now as that goes through the loop, all right, we are creating a temporary magnetic field. All right, so we can see here electric current goes through a loop, and then from there we can again see that now there is a temporary magnetic field in the coil of wire. From there we have a real magnet at the bottom. Okay, so let me show you that real magnet. So here's our real magnet right here, and that real magnet is going to interact with the temporary. So the real magnet interacts with the temporary magnetic field. Okay, and the result is we have pushing and pulling, and anytime you have that pushing and pulling, again, you'll see that that wire is not locked in, and so that wire can actually begin to spin. Right, so finally the coil begins to spin, and we now have kinetic energy when it started as electrical energy all the way up here. All right, so hopefully that makes a little bit more sense now that you've actually seen it in action. Same thing here, if you have parental supervision, feel free to look up how to make these. They're lots of fun to make, and your parents can make sure that you are staying safe while doing that. All right, let's go ahead and take a look at number 8. Again, we are turning this into motion. Pause the video, continue playing when you're ready. Okay, so at this point you should be able to answer this question completely on your own. We need to put the following steps into the correct order. All right, so we should be able to see how a real magnet, we have these 4 steps. A real magnet interacts with the temporary magnetic field. An electric current flows through a coil of wire. The coil of wire now spins. The coil of wire produces a temporary magnetic field. Again, think about which one of these makes sense to go first, second, third, and fourth. This is number 9. Again, you do need to complete this one on your own. If you need to review anything, just rewind. Pause the video, continue playing when you're ready. All right, so today we talked about how electricity and magnetism interact within a simple electromagnet, and then we also made it a little bit more complex by looking at a motor. Make sure you pause the video and reflect. How do you feel about today's objectives? If you feel very confused, please reach out to Mr. Bangle or Mrs. Sepulveda. Remember that both of them are very good at, are going to be your science gurus, right? Mrs. Sepulveda is our normal physical science teacher besides myself, so both of them can help you get individual tutoring on your projects, your exam in the future, or any other content that you might feel like you want help on understanding. Make sure you submit those 5B notes and make sure that you pass them. Thanks so much, everyone, and I will see you later.